All right, here we go. Welcome to the Crazy Hat Chemist, Stoichiometry and Dimensional Analysis. So this is a subsection here on a set of 7 different videos on basic stoichiometry problems without balanced equations. So we're first going to do these ones without balanced equations, and we'll eventually get to the balanced equation ones. So here we go, a subset of 7 videos. Here we go. Bam! Okay, so how many moles of titanium does 13 grams, 13.0 grams of titanium represent? So you're going to have this flow chart out all the time and a periodic table. So I want you to go grab a periodic table, pause the video if you don't already have one. So what do we have on this problem? We have grams. Grams is a mass. So that's what we have, is we have a mass. What is the question asking for? The question is asking for moles. So that's where we're going to end. So we're going to start at mass and we're going to go to moles. This is going to be a one-step problem here. So we're going to have 13.0 grams of Ti, that's titanium, and then we're going to use our periodic table to find out the molar mass of titanium. And that, you're going to find that right now, and that's equal to 1 mole. Okay, and we're going to cancel out our units. So we're starting off with grams, and then we're going to cancel out our units of grams so that we get moles. And this is what we're going to have. You should see that we're canceling out our units of grams right here. What's in this yellow rectangular box is a unit conversion. We talked about that previously. So the grams cancels out, and we're left with moles of titanium. Hopefully that makes sense for you. Okay, now I'm going to look at this and figure out how many significant figures I have in each number. 13.0, that's a trailing zero. Trailing zeros count with the decimal. That's why there's 3 significant figures in the 13.0. The 47.90, that's a measured value that's on the periodic table, and that's 4 significant figures. The 1 in 1 mole has an infinite number of significant figures because it's a definition. That is, 1 mole equals 47.90 grams. Remember, there are 2 reasons why we have an infinite number of significant figures. One is a definition, like in this example, and the other one is in counting. So when I count up the number of Ferraris that I have in my garage, 1, 2, 3, 4, 5 Ferraris in my garage, that means that the number 5 has an infinite number of significant figures. Just kidding on the Ferraris in my garage. Okay, this is the number that you get when using your calculator. That is 13.0 times 1 divided by 47.90 will give you this number. Now I need to round this number to the correct number of significant figures. And I'm using the least number of significant figures with multiplication division problems. So I have 3 significant figures, I have 4, I have an infinite. The least number of significant figures I have in this problem of the original numbers and the numbers that I'm using are 3. So I'm going to round this to 3 significant figures. So I'm looking at that 2, that 7, that 1, and then I'm going to look at this 3 right here for rounding. Remember, that leading 0 does not count, that's why I don't count that 1. So 3 is less than 5, therefore I'm going to truncate the number. That is, chop the number there in between the 1 and the 3, and this is the number I get. That is 0.271 moles of titanium. Okay? You could put this in exponential notation. That would be 2.71 times 10 to the negative 1 moles of titanium. That would be perfectly fine too. Okay? So what is the inverse of fun? Everybody likes to have fun. That's what we're doing here in chemistry because chemistry is so much fun. So what is the inverse of fun? Nuff. Okay? Nuff is the inverse of fun. And why is nuff so important here in chemistry, especially when we're doing dimensional analysis and stoichiometry problems? And nuff means number units formula. So if you see in my yellow answer there, the 0.271, that's my number. The MOL, those are my units, and the formula is TI. So I'm going to have a number, units, and a formula for every single answer for every single problem. Enough said about that, of course. So here's a little bit of humor here. This is mole humor. What do you call a 10th grader who is taking chemistry? A sophomore, of course. So we are just starting our dimensional analysis problems. That was our first one in a series of 7 on the basic ones. We do have 23 videos for this entire unit on stoichiometry. I'm not sure if this is the season that you're celebrating right now, but I hope it brings you a lot of cheer. I hope you have a fantastic day. See you later.